Welcome back. Today's video, we're going to talk about two topics, short but pretty important topics. Both of them have relationships to generalization and inheritance. So the first topic is how do we inherit attributes? In the last video on inheritance, we saw that inheriting methods from a superclass is fairly simple. You essentially call a superclass's methods as if it were your own. Just a quick reminder if you missed that, when we created this traffic light example, we had traffic lights of different kinds that we had created, and we were calling the operate method on all three of these traffic lights. But if you look at the source code that we created, this operate method only existed in the traffic light superclass. And my subclasses, so look at pixel traffic light, has no operate. Light strip traffic light has no operate, but they both work just fine because light strip and pixel both inherited the operate method from the superclass. Well, attributes, little different story. In most other object-oriented languages, attribute inheritance is fairly automatic. But in Python, attributes are only inherited if you call the superclasses init method. Because when you call the superclasses init method, you are initializing all the attributes in that init method. Now, if you don't call it, then you don't have access to the attributes, unfortunately. So you're going to ask, well, how would you ever have that situation where init is not called? Don't you always call init when you create an instance of a class? Yes, you do, except if you have a subclass which has its own init method. So for example, in this case, our pixel traffic light was a subclass of traffic light. That has an init method which only initializes this pixel attribute. Notice that it never calls the init method from the superclass, which means these red, yellow, green attributes are never initialized if you are creating an instance of the pixel traffic light. Well, what does that mean? That means pixel traffic light will not have access to those red, blue, and green attributes. For this example, it works out great because pixel traffic light does not need the red, blue, and red, green, and yellow, right? It only needs the pixel to control its stop, caution, and go methods. But what if we needed to access an attribute from the superclass? Well, there are a couple of ways you can get access to the attributes of the superclass. Obviously, you're going to have to make sure that the superclass's init methods are called. And there are a couple of ways to do this. You can use this super function or super method that gives you an instance of the superclass's object. And then you call the init from there with whatever parameters it needs. Okay, so that's one option. Or you can use the class name of the superclass dot init, and then you have to actually pass the self parameter as the first parameter, and then any of the parameters. If you're using this method, you do not need to send in self, but doing this method, you will need to send in the self parameters. The second option is the only way to do with multiple inheritance, and we're going to see that in a little bit. So let's take a quick example. A couple weeks ago, we did this example with a counter, right? And this was a fairly simple example where you had a display that shows a counter, and you hit the green button and that increases the count, and you hit the red button that resets the count to 0. Let's say I want to create a counter which also has a lifetime count, kind of like an odometer of a car, right? So that when you hit reset the trip or reset the current count, it only resets the current count but does not reset the lifetime one. Well, one way to do that would be to create a subclass of counter which has the odometer. So let's do that. So class counter odometer. And this is a subclass of counter. And I'm going to create a def init. And here we'll create an odometer and set that to 0. And let's call increment. We're going to override the increment method. And here we're going to increase the odometer by 1. Great. And then we can get the odometer back and we say def odometer. And that simply sends back. All right. So that's basically what this counter class does. And now in my controller, let's say I want to display the count in one line, the current count in one line, and the lifetime, the odometer in the next line. So we will basically take this and make a copy of that. And here we're going to show the odometer. And this is going to have counter.odometer. And we will display that in line 1. So this was displaying by default in line 0. And this one will display in line 1, which is the blank line below. All right. So, and in order to use this, we're going to use the counter odometer class. Now you will see this will have a few problems and we will explain and we will solve those problems as we run into them. So I'm going to try to run this. And the first problem we get is that line 44 is saying counter odometer object has no attribute number. Well, let's look at line 44. What it's trying to do is trying to return self.number. Notice that this is not in the counter odometer class, it's in the counter class, but it's saying counter odometer object has no attribute number because I have a counter odometer object here and I am calling current. I'm saying current, and current, there is no current in counter odometer, so it's inheriting the current method from counter, and it still can't access the number class because it was never created. So how do we fix that? As we said, we need to make sure that the superclasses init method is called. So we will use the first method in here. We'll use this way of doing it. This is the simpler way. We'll say super dot init, and that's it, because the superclasses init method does not take any parameters. And that should solve this problem. All right, so let's run it. Okay, so now you get count 0, odometer 0, no errors. If we hit the increment button though, now we see the second problem. Odometer is increasing, but notice that the current count is always 0. What happened there? So if you look at the increment method, we overwrote the increment method from counter. So this method, which was incrementing the current count, is no longer called. It is completely occluded by this increment method, which has overridden the superclasses method. So how do we call the superclasses method? Well, same solution. We say super dot increment. And now this is first going to call the superclasses increment method, and then it will do whatever it needs to do for this own class. So now if I run this, now we will see that now our count is also increasing, odometer is also increasing, but if we hit the reset button, it should only reset the count, but will not touch the odometer. And there you go. Count gets set to 0. Odometer is not touched. So if I increase, notice that odometer keeps increasing. Count is only showing the current trip. And that is how you inherit attributes from a superclass, as well as if you need to call an overridden method from the superclass, you can use this way of calling the superclasses method. Great. So the next thing that we're going to talk about, and again, another small concept, but pretty important nonetheless, is a concept of multiple inheritance. Now, there is a lot of arguments about whether multiple inheritance is a good thing or bad thing. Languages like C++, for example, had support for multiple inheritance, but Java, then I believe Swift as well, decided to do away with multiple inheritance and instead used abstract classes and interfaces to implement something similar to multiple inheritance. All of that has to do with complexity of compiling and things like that. Python is not a compiled language, so Python actually fully supports multiple inheritance. It is entirely up to the programmer to make sure that you do not have any runtime issues with it. Okay, so what is multiple inheritance? So let's say you have a class called flying thing, and you have subclasses like airplane. Airplane is a flying thing. Helicopter is a flying thing. Then you have a class called animal. You have subclasses like wolf, horse. They are subclasses of animal. Let's think of a class called bird, right? A bird inherits from flying thing. Well, it is a flying thing, but bird is also a living animal, right? So it inherits from both flying thing as well as animal. And that is called multiple inheritance. And in Python, we do have multiple inheritance, so we can take advantage of that. So let's do a quick example of how we can use multiple inheritance in Python. So let's go ahead and create a new project today. Okay, so we're going to go to Pi Pico, Raspberry Pi Pico, MicroPython. And this is going to be a super simple project. We're going to create a sensor-controlled light. Right? Many of you probably already have one like that at home, where, as you know, when the ambient light gets dark, the night light sort of comes on, right? And when the light, when the sun comes up, the night light turns off on its own. So as it's getting darker, the internal light gets brighter and vice versa. So let's create that with a light sensor. So we're going to create a light. We're going to add a resistor. And we're also going to add a light sensor. And if you look at the sensors here, this one, the photoresistor LDR sensor, is actually a light sensor that's available in the simulator. I'm going to hit the R button to turn it so that we can kind of see them. And let me line up the LED. Let's use which LED color should we use? Let's use the yellow LED. I think that would be the easiest to see, or maybe the green might be easier. Let's see. All right, so I think my green LED is connected to pin 8, so we'll connect that to pin 8, that to the anode, and we will take the ground and connect that to the cathode. Okay. Now, for the analog sensor, interesting to note that this sensor package actually has an analog output as well as a digital output. So you can set up a threshold. If the light is beyond a threshold, it will turn on or it will trip. If it's lower than the threshold, it will turn off, right? And you can adjust that threshold using this potentiometer that is built into the case. We don't need the digital output. We're going to use the analog output so we can actually control the brightness of our light here. So let's connect the analog output. Now, when you connect the analog output, you will see that only 3 of the I/O pins of the Pico light up. And that's because only 3 pins in the Raspberry Pi Pico are capable of doing analog output. There's something called analog to digital converter, or ADC, and there are 3 of those built into the Pi. In the box, I connected the light sensor to pin 27, which is where we are going to connect this one. And then let's connect this one to ground and the VCC pin to VCC. All right, that is all the connections we need for this project. Now what we're going to do is we're going to create a sensor light, right? So we will create a class sensor light. And this class is going to be a subclass of light because it's a light, but it's also a sensor. Okay, and it's actually a subclass of a dimmable light. So not just a regular light, digital light that turns on and off, but it's something that I could change the brightness. So we will say sensor light is a subclass of dim light. That's my class for dimmable lights, and it's also a subclass of analog sensor. Now, in order to use these two classes, we need to import them from our Pico library. So let's go ahead and upload. We will need to upload lights.py. We will need to upload log.py, and we will need to upload sensors.py. And all of these are available from the Pico library GitHub repository, which we have been using. All right, so this is our sensor light class, and notice that it is inheriting from both dim light and analog sensor. So that's what multiple inheritance does. So now when we create and the init method, and let's say the sensor light will have a pin for the light. So let's call that a light pin. Let's have a sensor pin. And let's use a name just like we have been using for our other classes as well. Now, we need to initialize two superclasses, which means we can't use super anymore, right? Because we have two superclasses. Super is going to cannot return two things. So we can't use super. So we'll have to use this second method of using, which is the superclass name .init. And remember, extremely important to make sure that you put the self as the first parameter and then provide any of the parameters. And I can show you what happens if you forget to do that. So let's go ahead and say dim light dot init and self, and it will need to get the light pin, and let's say light. So since I have a single name and I'm creating two different things to distinguish them, I'm going to call the light one as whatever name we get plus light, and the sensor let's say we forget to use the sensor, right? We'll say sensor pin name plus sensor. Watch what happens when I try to use this. How do we operate this thing? Well, what we could do, and this is how the analog sensor works. Analog sensor, when you call, there is a method in analog sensor called raw value. And if you look at that method, there's the analog sensor. It basically returns you a 16-bit value from the sensor, which means it'll be a value between 0 to 65,500 something, right? But dim light has brightness level from 0 to 255. So we need to take the value from the sensor and we kind of tone it down to the level that we want the light to go. So let's create an operate method. I could name it whatever I want, but don't need anything in there. Basically, what I will do is I'm going to say, let's get the current sensor value. So we'll say V equals self dot raw value. Notice that I could say self dot raw value because I am inheriting the analog sensors raw value class. Multiple inheritance methods are immediately inherited. What I'm going to do is, since this is a number between 0 to 265,556, I'm going to divide that by 255 so that it becomes a number between 0 and 255 to determine the brightness. So we'll say brightness equals V divided by 255. And what I'm going to do is I'm going to convert that value into an integer because my set brightness method only takes a value between 0 and 255, and it's an integer value. So I'm going to say brightness. So that's what operator does. It takes the sensor's value and it sets the value according to that sensor. Now let's create an instance of this. So we will say L equals sensor light. And the light pin is pin 8. And sensor pin is 27. And let's give this a name. Let's say bathroom. So let's say my bathroom has a one of these sensor lights so that when it's dark, the sensor light lights up, so whoever goes into bathroom can see what's in there before they turn on the light switch. And now what we can do is we can create a while loop, and we just say L dot operate. And let's also wait for a little bit. Let's say half a second each time. All right, let's save this as project 2. And we're going to run it. Now we will see one problem, and that I told you that, oh, okay, it says dim light isn't defined. And I think you guys should know what that error is now. It's trying to access the dim light. Well, we have uploaded them, but we have not imported them. So we need to make sure we import these classes. So we have to say from lights, import star, from sensors, import star. So then those are available in our main program. Let's run it again. Now I have this weird error. It says int object has no attribute pin. And if you look at that, that has something to do with the sensors class. And it is very confusing. It would be weird to see, why did this happen? Well, it happened because an error that we did by mistake. When you are calling the superclasses methods, you need to make sure you pass self as the first parameter. Otherwise, you're going to end up getting errors like this. Okay. Now we save it, run it. Now notice that our sensor light goes on, and let's see how this thing works. So what I'm going to do is, this is a simulator, so we're going to simulate the brightness. Let me lower it so you can see the light. So here is the brightness simulator, and you'll see that if I increase the brightness, like all the way up, the light turns off. But if I reduce the brightness and reduce the light sensor, the light becomes bright. And you can kind of see the brightness value is now 254, which is about full brightness. And as we are increasing the amount of ambient light, the brightness is going down and down and down and down and down. Ultimately, when it's like full brightness, it goes down to almost 0 when the light turns off. So that's an example of how we can use multiple inheritance to create something, this sensor light, which inherits both from light as well as from analog sensor. Actually, it is super simple to even show this in real hardware. So let's switch over to the hardware. And since this is a small enough example, we should be able to do this without even needing to fast forward through this. So we'll just go to Tawny and we will open up main.py. We'll put this main.py in there and we'll copy this to our Raspberry Pi and let's run it. And now notice that our bathroom sensor, right? The brightness is 137. That's about midway, looks like. Now, the photo sensor in this package, I actually installed in this box. That, I don't know if you can see that very well, that is the photo sensor, right? Now, you can see that the green light is on, but if I cover the sensor, you see that the green light gets a lot brighter. Now notice that our brightness is pretty high now. And if I remove it, the brightness sort of goes down. And if I flash a flashlight on it, I should be able to turn it really low too. So let me use my flashlight. And let's see if I can show you if I take a flashlight and sort of bring it closer, 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 and you can kind of see that the green light turns off. When I remove it, green light turns back on. Flashlight on it, light goes off. So now we just implemented in hardware a light sensitive light that automatically turns on when it gets dark and turns itself off when it gets bright. And that's how a multiple inheritance works in Python. Hope this was useful, and I will see you in the next video.